Factorising an algebraic expression means to put it into brackets. This is the opposite of expanding brackets. For example, if we had the expression 6a add 2, in order to factorise, we need to look at the terms in the expression and find the highest common factor of those terms. The highest common factor will go on the outside of the brackets. To find the factors of 6a, we can ignore the a for now and list all the factors of 6. We know that 6 multiplied by 1 is 6, and 2 multiplied by 3 is 6. So 6, 1, 2 and 3 are all factors. Then we look at the other term in the expression, 2. 2 only has 2 factors, 1 and 2. So the common factors between 6a and 2 are 1 and 2, and the highest of these common factors is 2. This means 2 goes on the outside of the brackets. Now we need to find what we multiply this factor by to get each original term. To get 6a, we multiply 2 by 3a, so 3a goes inside the brackets. To get 2, we multiply 2 by 1, so the other term inside the brackets is positive 1. This gives us the final answer of 2 open brackets 3a add 1 close brackets. If you wish to check your answer is correct, you should be able to expand the brackets to get back to the original expression. Here is another example. If we had 15b add 10, we can factorise this expression by finding all the factors of 15 and 10. The highest common factor is 5, so 5 goes on the outside of the brackets. To get 15b, we would multiply 5 by 3b, so 3b goes inside the brackets. To make 10, we multiply 5 by 2, so positive 2 is the other term inside the brackets. This gives us the final answer of 5 open brackets 3b add 2 close brackets. Have a go at this yourself by factorising this expression. Pause while you find the answer. Here is the answer. You may need to factorise expressions containing negative numbers. For example, 9d subtract 21. To find the highest common factor of these terms, it helps to ignore the negative sign for now and work out the highest common factor of 9 and 21, which is 3. So 3 goes on the outside of the brackets. Then, to get 9d, we would multiply 3 by 3d. So 3d goes inside the brackets. To get negative 21, we multiply 3 by negative 7. So negative 7 goes inside the brackets. This gives us the final answer of 3 open brackets 3d subtract 7 close brackets. Here is another example. If we factorise 40 subtract 16e, the highest common factor of 40 and 16 is 8, so 8 goes outside of the brackets. To get 40, we multiply 8 by 5, so 5 goes into the brackets. To get negative 16e, we multiply 8 by negative 2e, so the final answer is 8 open brackets 5 subtract 2e close brackets. Have a go at factorising these expressions. Pause while you find the answers. Here are the answers. You might find when factorising that the common factor is a variable. For example, if we had a squared add 5a, there are no number factors of a squared. However, when both terms have a matching variable, like a, that variable goes outside of the brackets. We know that a squared is a multiplied by a, so a goes inside the brackets. We can also see that a is multiplied by 5 to make 5a, so the final answer is a open brackets a add 5 close brackets. Here is another example. 12b subtract b cubed. Here the terms have the common variable of b, so b goes outside of the brackets. b is multiplied by 12 to get 12b, and b is multiplied by negative b squared to get negative b cubed. So the final answer is b open brackets 12 subtract b squared close brackets. Have a go at factorising this expression. Pause while you find the answer. Here is the answer. You might have a number and a variable outside of the brackets. For example, if we had 14d add 7d squared, here we can see d is a common factor, but as 14 and 7 have the highest common factor of 7, 7d goes on the outside of the brackets. 7d is multiplied by 2 to get 14d, so 2 goes inside the brackets. And we would multiply 7d by d to get 7d squared. So the final answer is 7d open brackets 2 add d close brackets. Here is another example. 8e subtract 6e squared. Here we can see e is in both terms, and that 8 and 6 also have the common factor of 2. So outside of the brackets we put 2e. To get 8e, we multiply 2e by 4, so 4 goes into the brackets. To get negative 6, we multiply 2 by negative 3, and e must be multiplied by e to get e squared, so inside the brackets we put negative 3e. So the final answer is 2e open brackets 4 subtract 3e close brackets. Have a go at factorising these expressions. Pause while you find the answers. Here are the answers. When factorising, it can be possible to have more than one variable outside of the brackets. So if we had the expression 2ab add ab squared, we can see both terms contain a and b, so we can write ab outside of the brackets. ab is multiplied by 2 to get 2ab, so 2 goes inside the brackets. To get ab squared, ab has been multiplied by b, so the final answer is ab open brackets 2 add b close brackets. Here is another example. 24 s squared t subtract 6 st squared. We can see both terms contain the matching variables of s and t, and as 24 and 6 have the common factor of 6, we write 6st outside the brackets. To get 24, 6 has been multiplied by 4, and to get s squared t, we would multiply st by s, so 4s goes inside the brackets. To get negative 6, 6 is multiplied by negative 1, and to get st squared, st is multiplied by t. We don't need to write the 1 inside the brackets if the term also has a variable. This gives us the final answer of 6st open brackets 4s subtract t close brackets. Have a go at this yourself by factorising these expressions. Pause while you find the answers. Here are the answers. Here is a summary on what we have learnt about factorising single brackets. Factorising means to put an algebraic expression into brackets. To factorise, we find common factors of the terms in an expression and put these outside of the brackets. These can be numbers or variables, or a combination of numbers and variables. We then find what the factor outside the brackets has been multiplied by to get each term, and put the answers inside the brackets. To check you have factorised correctly, you should be able to expand the brackets to get back to the original expression.